Hey guys, how are you today? Hope you're doing well. We are going to be doing more conversions using the factor label method today. Yesterday, we got our conversion factors from the Z chart. Today, we're going to be doing the same thing we did yesterday. The only difference is we're going to get our conversion factors from these three charts that I have posted here in your interactive notebook for today. So, we're going to be doing the same type of thing using the factor label method to do conversions, except we're not going to be converting from one metric unit to another. We're going to be converting between metric units and standard units. Okay, standard units are the English units. They're what we use in the U.S. Almost every other country in the world except the U.S. uses the metric system. They use grams and kilograms, and they use liters and milliliters and meters and centimeters. But here in the U.S., we don't use those units. We use feet and inches and yards and miles and feet. And we use ounces and pounds, and we use fluid ounces and gallons and quarts and pints. Okay, so those are English units or standard units, and we're the only country in one of the only countries in the world that uses those standard units. Most countries in the world use the metric system. So, if you are, maybe you have a recipe that is in metric units and you only have standard measuring cups, tablespoons and cups and things like that, then you may need to convert from those metric units to the standard units so that you can use your measuring utensils if you don't have utensils that measure in metric. The same is true maybe for someone the tools, maybe you have a European car, but your tools are American. Well, the American tools are going to be in 3/4 and 1/8 of an inch, whereas the metric tools are in millimeters, a 7 millimeter wrench, an 8 millimeter wrench. So again, you may need to convert between standard units and metric units, or between metric units and standard units. And these charts that I have, I just got these off the internet. I just went ahead and put them on here for you so you would have them to use. They give us the conversion factors that we need to use the factor label method to convert between metric units and standard units. So that's what we're going to be doing today. We're going to be doing the exact same thing that we were doing yesterday. We're just going to be converting using standard units and using these conversion charts to get our conversion factors rather than using the Z chart. We use the Z chart when we want to convert from one metric unit to another. When we want to convert between English and metric units, then we're going to use these conversion charts. So I have 3 conversion charts on here. I have one that shows us different conversion factors for length, going between inches and centimeters, yards and centimeters, yards and meters, miles and meters, miles and kilometers, so on and so forth. Lots of different conversion factors here. Then this chart converts liquid volume, so we can go between teaspoons and tablespoons, cups and ounces, milliliters and ounces, liters and pints and ounces and gallons and liters and all that good stuff. And then this is our metric conversion chart for weight. So again, we get to convert between ounces and pounds and grams and ounces and kilograms and pounds and all those good things on this one. So there's lots of conversion factors here, and we'll go through today more of how we decide which one it is that we need to use, but it's going to be very similar to what we did yesterday. So you only have 2 slides of problems to do today. So these are the problems, again, as we've been doing. You have to show me your work. So the problems are here. Even though you may think, oh, well, I can just multiply this or divide this. You must do it using the factor label method, just like I showed you yesterday, just like I'm going to show you again today. You must do it on a piece of paper, show your work, using the factor label method, canceling out the units that you're trying to get rid of and ending up with the units that the question is asking you for, and then take pictures of that work and insert it on the slides here. Again, you can do all 5 of these problems on one page in one picture and put that one picture here to the right of the problems, and the same way on this slide. So that way you've got 2 pictures to put on here instead of 10, just 2. Do all 5 of these on one page and put that picture on this slide. Do all 5 of these on a different page and put that picture on this slide. And that'll make it easier for me to grade, and it'll make it easier for you to get those pictures on here. Make sure that you do number each problem. Please try to do them in order and number each one so that it will make it easier for me to check your answers. The easier you make it on me, the the better off you're going to be in the long run. So these are practice problems for you to do. I have some of my own that we're going to do over here, so that way all of these will be practice for you. Now, the ones that I'm going to do are very similar to the ones that you have on here. So in some cases, it's just the numbers that are different. I'm going to be doing only 6 practice problems where you have 10 on here. So again, we are going to be using these 3 charts to get our conversion factors. So let's go ahead and look at the first problem that we want to do. The first one we want to do, we have 4.5 liters and we want to convert that to gallons. So remember, what's the first thing we do? We take what we are given, which this part right here is what we're given, and we put it over 1. So 4.5 liters over 1. Okay. Now we're going to set up our second ratio. Again, remember, we don't want liters anymore. We want gallons. So we need to cancel out liters. So and again, remember, we're not worrying about numbers right now, just the units. So where do I need to put liters in this ratio to cancel it out? I hope you said on the bottom. So we're going to put liters on the bottom. What we want to convert to is what's going to go on the top. So in this problem, we want to know gallons. That's what we're solving for. So we're going to put gallons on the top. That way our liters will cancel out because we have one on top, one on bottom. Now we're ready for numbers. Where do we get our numbers? Conversion factors. So this is where we're going to go back and we're going to use those 3 conversion charts. Now, we have gallons and liters. We have 3 conversion charts here. We have length, we have liquid volume, and we have weight. So gallons and liters would be length, liquid volume, or weight. I hope you said liquid volume. So what we need to do is we need to look for a conversion factor that has both of these in it, gallons and liters, and hopefully there will be one. So let's see. Here's gallon, but it's got quart, gallon and ounces. There's liter and ounce, liter and pint. There's ounce and milliliter. Okay, here's gallon and liter. So that's the one we need to use because, again, the conversion factor that we're going to use is going to have both of these in it. If it doesn't, then we're going to have to do more than just this one step. We're going to have to do another step, and we're going to have to use 2 conversion factors just like we did yesterday. But luckily, we found a conversion factor that has both gallons and liters in it. So that's the one that we're going to use. So 1 gallon is 3.7854 liters. So if it's 1 gallon in the conversion factor, it's 1 gallon in the problem. If it's 3.7854 liters in the conversion factor, then it has to be 3.7854 liters in the problem. So again, remember, whatever number is in front of that unit in the conversion factor, that has to be the number in front of that unit in the problem. So 3.7854 liters in the conversion factor, 3.7854 liters in the problem. Okay, now we're going to use our calculator, and I forgot to look that up, so let me look that up real quick. Okay, so remember, we got to multiply across the top. So 4.5 times 1 gallon is 4.5 gallons. On the bottom, 1 times 3.7854, again, liters has been canceled out, so that's not there anymore, is 3.7854. Okay, now we're going to divide. 4.5 divided by 3.7854. So 4.5 divided by 3.7854. And there's our answer. Now, what we're going to do for the sake of time right now is, you guys, we're going to round to 2 places past the decimal. Okay, now there is a way that we know exactly how many digits to put in our answer, exactly how much to round, but I'm not going to go into that just yet because I just want us to learn how to use this factored label method first, and then we'll go into how to round it better later. So for now, let's just say, let's make all of our answers 2 places past the decimal. So 2 places past the decimal would be 1.18. But notice, after this 8, there's another 8. So if that number is 5 or greater, then this number has to round up. So 1.188 rounds to 1.19. So my answer is 1.19. And then don't forget your unit. Your unit is gallons. Again, in the end, after you have set this up so that the units cancel, the unit that you have left should be the unit that you were solving for. So our answer is 1.19 gallons. Okay, let's try another one. 12 inches is equal to how many centimeters? So again, we're going to take what we were given and put it over 1. 12 inches over 1. Next, we're going to set up our next ratio. we need our inches to cancel out because we want centimeters instead. So inches will go on the bottom so that it will cancel out. What we're solving for, which is centimeters, will go on the top. So now inches will cancel out. Now we need to find a conversion factor that has both centimeters and inches in it. Again, once we get our unit set up so that the one that we're given is canceled, now we're ready for numbers. To get our numbers, we use our conversion factor. So we need to find a conversion factor that has both centimeters and inches. Again, we have three charts: length, fluid, volume, and weight. Centimeters and inches are length. So I need to find a conversion factor on the length chart that has both centimeters and inches in it. So here's my length chart. Here's centimeters and inches right here. You guys, if you go down here, you have inches and centimeters. It doesn't matter which one you use, you're going to get the same answer. So since I found this one first, centimeters and inches, I can just go ahead and use that one. But if you want to use this one, you're going to get the same answer. Okay? So I'm just going to go ahead and pick this one because this number's longer, and that'll be more I'll have to remember. So I'm going to use this one. 1 inch is equal to 2.54 centimeters. So 1 inch in the conversion factor should be 1 inch in my problem. 2.54 centimeters in the conversion factor should be 2.54 centimeters in my problem. Again, the number that's in front of the unit in the conversion factor must be the number that's in front of the unit in the problem. So 1 inch, 2.54 centimeters. Now that we've set it up, our inches have canceled. Centimeter is what we're looking for, and that's what we're going to have left. Now we can do our multiplying again. Multiply what's on the top, multiply what's on the bottom. So on the top, we have 12 times 2.54. So 12 times 2.54. And that gives us, and again, I'm going to do 2 places past the decimal, and that's what it gives me, so 30.48. So 30.48 centimeters on the top. On the bottom, 1 times 1 is 1. Now we're going to divide. 30.48 divided by 1 is 30.48 centimeters. Notice the unit that I'm left with is the unit that I'm solving for, so that is the correct answer. Okay, let's move on to another one. 37 ounces is how many liters? So what we're going to do first, take what we're given and put it over 1. So 37 ounces over 1. Set up my next ratio. I want to get rid of ounces and solve for liters, so I need to cancel ounces out. If ounces is on the top, it needs to go on the bottom in this second ratio so that it will cancel out. What I'm solving for goes on the top, so I'm solving for liters, so liters goes on the top. Now my ounces will cancel out, and I will be left with liters. Now I need to find, now I'm ready for numbers. I need to find a conversion factor that has both liters and ounces in it. So again, remember, we have a length, of a fluid volume, and a weight. Which one of those do I need to use? Liters and ounces, I hope you said our fluid volume. If you're not sure, check until you find the one that you need. But I know that liters and ounces are volume, fluid volume. So I'm going to go to the fluid volume chart and look for a conversion factor that has liters and ounces. So here's the fluid volume chart. Here is liter and ounces right here. Okay? So we have 1 liter is 33.814022 fluid ounces. And you guys, I'm going to round that to 2 places past the decimal just because I can't remember all that. So 1 liter in my conversion factor, 1 liter in my problem. 33.81 ounces in my conversion factor, 33.81 ounces in my problem. Again, the number that is in the conversion factor, the number in front of the unit in the conversion factor must be the number in front of the unit in the problem. So 1 liter, 33.81 ounces. 1 liter, 33.81 ounces. Now that I have my numbers plugged in, now I'm ready to solve. Multiply across the top. 37 times 1 is 37. And again, I still have that liter unit. On the bottom, 1 times 33.81 will give me 33.81. Now we're going to divide. 37 divided by 33.81. 37 divided by 33.81. And again, I'm going to round this to 2 places past the decimal. 1.09, that's where I'm going to stop. But notice this is a 4. Okay, that is not 5 or greater. So then what I do, I just drop that. I do not have to round this up. So it's 1.09. 1.09. And again, my unit is liters. Remember, do not give me an answer without a unit. Liters should be the one that I have because it's the one I'm solving for, and it is the one that I ended up with, so that is correct. Okay, let's look at another one. 135 ounces equal to how many kilograms? Okay, so 100, we're going to take what we're given here and we're going to put it over 1. 135 ounces over 1. Always take what you're given and put it over 1. Okay, now we're going to set it up so that our units cancel out. Ounces is on top, so ounces should go on bottom. What I'm solving for goes on top in this second ratio. I'm solving for kilograms, so it goes on top. Now my ounces will cancel out. Now I'm ready for numbers. Now that I have it set up so that my units cancel, I'm ready for numbers. I need to find a conversion factor that has both kilograms and ounces. You guys, there's two different kinds of ounces. There's fluid ounces and there's weight ounces, okay? So this was fluid ounces, okay? Fluid ounces. This is not fluid ounces. How do I know that? Because I have kilograms here. I know kilograms is a weight. Okay, so if you're not sure, look on the charts until you find one that has both kilograms and ounces in it, a chart that has kilograms and ounces on it. So when you look here, this one has fluid ounces, but there's no kilograms, so I know that can't be it. I've got to use the weight chart. So I need kilograms and ounces. Right here, I see a conversion factor that has kilograms and ounces, so I can use that one. Here I have ounce and gram. Okay, that's close, but still not exactly what I need, so I'm going to use this one because it's going to be easier for me. 1 kilogram is 35.27396 ounces. Again, whatever number is in front of the unit in the conversion factor must be the number in front of the unit in the problem. So 1 kilogram, 1 kilogram. 33, and you guys, I'm going to round this to 2 places past the decimal just to make it easier on myself because I don't want to have to remember all those numbers. 35.27 ounces in the conversion factor. 35.27 ounces in my problem. Now I'm ready to solve. Multiply across the top. 135 times 1 kilogram. Again, remember, ounces canceled out. 135 times 1 kilogram is 135 kilograms. On the bottom, 1 times 35.27 is 35.27. Now we're going to divide. 135 divided by 35.27. So 135 divided by 35.27. And again, I'm going to round this to 2 places past the decimal, 3.82. Before I write that down, notice there's a 7 after the 2. Since that's 5 or greater, that causes the 2 to round to a 3. So this is 3.83. So the answer is 3.83 and kilogram. Again, I'm solving for kilograms. That's what I got in my answer, so I'm good. Moving on. 222 yards is equal to how many miles? So I'm going to take what I'm given, put it over 1. So 222 yards is equal to how many miles? So 222 yards over 1. Set up my ratio. Now I want to cancel out my units. Yards is on top. Yards has to go on bottom. What I'm solving for goes on the top in this second ratio. So now my yards are going to cancel out, and I'm going to be left with miles. So I've got to find a conversion factor that has both yards and miles in it. Well, you guys, I know that miles is a length. If you don't know, search the 3 charts until you find yards and miles on the same chart. So this chart does have yards and it does have miles. However, can we find a conversion factor that has both yards and miles in it? We can right here. 1 mile is 1,760 yards. 1 mile is equal to 1,760 yards. So 1 mile in the conversion factor, 1 mile in my problem. 1,760 yards in the conversion factor, 1,760 yards in my problem. Okay, so make sure the number that's in front of the unit in the conversion factor is the same number that's in front of the unit in your problem. This is where students mix up the most. They will end up putting the wrong number in front of the wrong unit from their conversion factor. You guys, all it is a matter of just copying. 1 yard here is 1 yard in your problem. 1 mile here is 1 mile in your problem. 1,760 yards here is 1,760 yards in your problem. So just use that conversion factor and copy the numbers directly over, making sure you put them in front of the correct unit. Okay, now we're ready to solve. Multiply across the top. 222 times 1 mile is 222 miles. On the bottom, 1 times 1,760 is 1,760. Now we're going to divide. 222 divided by 1,760. 222 divided by 1,760 gives me, again, I'm going to round to 2 places past the decimal, 0.12. Notice that after the 2, there is a 6, which means I need to round the 2 up to a 3. So 0.13. 0.13, and this is miles. Again, notice I'm left with miles, the unit miles in my answer, and that's the unit that I should have. Again, guys, the key to the factor label method are the units. Set your problem up so that your units cancel. Make sure when you're getting those numbers from the conversion factor that you put the number in front of the correct unit. At the end, make sure that the unit that you're left with is the unit that you're solving for. The factor label method is all about the units. Okay, we're going to do one more example. 1,575 milliliters is equal to how many quarts? So 1,575 milliliters over 1. Again, I'm taking what I'm given and putting it over 1, making it a ratio or a fraction. That's always my first step. Next, set up my second ratio. Remember, units need to cancel. In this case, I'm canceling out milliliters. Milliliters is on the top here. It must go on the bottom here. Then the unit I'm solving for goes on the top here, quart. Okay? Now, milliliters is going to cancel out, and I'm going to have quart left as my answer. Now I'm ready for numbers. Where do I get the numbers? From my conversion factor. So, quarts and liters and milliliters, that is a liquid volume. If you're not sure, look at all 3 charts until you find one that has both quarts and milliliters on it. So liquid volume has quarts and it has milliliters. So I need to find a conversion factor that has both quarts and milliliters. So let's see here. Here's milliliter, but that's ounces. I need quart and milliliter. Okay, here's milliliter and ounce. Here's milliliter and pint. Where's quart? Okay, here's quart. The only place on this whole thing where we have quart is right here. And it says 1 quart is equal to 2 pints. So you guys, this is going to be one of those 2-step problems where if I can convert quarts to pints, then can I convert pints to milliliters? Yes, I can right here. Pints is equal to this many milliliters. So what I'm going to need to do in this problem is I'm going to have to go from milliliter to pint and then from pint to quart, because I do not have a conversion factor that has both milliliters and quarts. Okay, I have milliliters and ounces. I have milliliters and pints, but I don't have milliliters and quarts, but I do have quarts and pints. So if I can do milliliters to pints, then I can do pints to quarts and I can get my answer. So rather than having quarts here, we're going to have to change this to pint. Okay, so we're going to do this, milliliter to pint. Okay, and then that's going to get rid of milliliter. I'm going to have pint. But now, again, I don't want pint. I want quart. So I'm going to need another ratio here, and I want to cancel out pint, so put it on the bottom so that it'll cancel out, and then change it to quart, which is what I'm solving for. Okay, so I need to do milliliter to pint first. So which one did we say has milliliters and pints? Okay, it was this one. 1 pint is equal to 473.17648 milliliters. So 1 pint in the conversion factor, 1 pint in my problem. 473.1, and I'm going to round that to 2 places, so 176 is 1/8. 473.18 milliliters in my conversion factor. What was it again? 473.18 is 473.18 milliliters in my problem. Again, 473.18 milliliters in my conversion factor is 473.18 milliliters in my problem. Okay, so that first conversion factor had pints and milliliters. So those numbers go in this ratio with pints and milliliters. 1 beside pint and 473.18 beside milliliters, because that's what I have in my conversion factor. 1 beside pint, 473.18 beside milliliter. Okay, now I need to find one that has quarts and pints. Okay, and that was this one. 1 quart is 2 pints. So 1 quart in my conversion factor, 1 quart in my problem. 2 pints in my conversion factor, 2 pints in my problem. Okay, now we're ready to solve. 1575 times 1 quart. Well, that's 1,575 quarts. Okay, on the bottom, we have 1 times 473.18 times 2. So 1 times 473.18 is 473.18 times 2 gives me 946.36. So 946.36 is on the bottom. Now we divide. 1575 divided by 946.36. So 1575 divided by 946.36. And that gives me this. Again, I'm going to round to 2 places past the decimal. That's 1.66. This 4 is not big enough to change this 6, so it's just 1.66. So this is 1.66 quarts. Again, notice the only unit that I'm left with is the unit in my answer is the unit that I'm solving for. So again, guys, you may have to do a 2-step problem just like what we did yesterday. If you cannot find a conversion factor that has both of your units in it, like we could not find one that had both milliliters and quarts, then we had to find 2 conversion factors that had something in common. So milliliters to pints was our first one, and then pint to quart was our second one. They both had pint in common, so we had to change from milliliters to pints, and then from pints to quarts. So you may have 1 or 2 on your problems today, on your practice for you to do, where you may have to do 2. You may have to do 2 ratios instead of just 1. So make sure you remember that. Again, make sure that you're doing this on paper, setting it up so that the units cancel, getting the numbers from your conversion factor and plugging them into the problem in front of the correct unit, multiply across the top, multiply across the bottom like I did here, and then divide the top by the bottom to get your final answer. And you can round your final answer to 2 places past the decimal for the time being. Please let me know if you have any questions. Have a great day. Bye-bye.